So this is a quick video to assist you in interpreting Z-scores. So just a quick recap of the normal distribution curve that you would have covered in ECP the end of last year. As you remember, I hope, it is a symmetrical graph. The normal distribution graph is a symmetrical graph. The mean value is in the middle, and we calculate 1, 2, and 3 standard deviations above and 1, 2, and 3 standard deviations below the mean. So certain percentages are going to be useful, and you'll need to remember these values. So the first value you need to remember is that on a graph from a group of data, 50% of the data falls above average. Okay, in terms of where the mean is, 1 standard deviation above the graph, the mean represented on the graph would represent 16% of the population. Compared to the mean, 2 standard deviations above the mean would be represented like that on the graph, and that in terms of percentages would be 2.5% of the population. And in comparison to the mean, 3 standard deviations above would be that tiny little tail on the graph, and it's represented by 0.15% of the population. So in terms of our normal graph, 50% of our data, doesn't matter what size the group of people that you've surveyed or the group of data, it doesn't matter how big the group is, the number of data, 50% of the values will be above the mean. 16% of the values will be 1 standard deviation above the mean. 2.5% of the population, or 2.5% of the values, will be 2 standard deviations above the mean, and 0.15% of the population, or the group, the number of data, 0.15% of those pieces of data will be 3 standard deviations above the mean. So it doesn't matter how big the values are, how big the group is, those 4 percentages will always be the same. 50%, 16%, 2.5%, 0.15%. They're the 4 values you need to remember for interpreting Z-scores. And because of the symmetrical nature of the normal graph, the same thing applies going the other way. So below average, 50%. One standard deviation less than the mean is represented by 16% of our population. 2 standard deviations below the mean would be represented by 2.5% of our population, and 3 standard deviations less than the mean represented by 0.15% of the population. So if we had 100 pieces of data, for example, 50 of those data will be less than the mean, 16 of those data will be 1 standard deviation less than the mean, 2.5 of them will be 2 standard deviations less than the mean, and 0.15 of them would be 3 standard deviations less than the mean. So those 4 values, left and right, on a normal distribution graph are important numbers to remember. So in terms of the normal graph, normally we say this part of the graph is above average, or the top part of the group, and we say this part of the graph is below average, and they are the bottom part of the group. So for example, in a test, a SAC scores or something like that, we take, if we're looking at it and saying it's normally distributed, the mean SAC score sits in the middle of this graph, and all the students that are above average go to the right-hand side of the graph, all of the students that are below average go to the left-hand side of the graph. And because of the nature of the distribution of this data, we can pick out percentages that would fall in which sections of the graph. So sometimes we'll calculate Z-scores. The actual calculation is very straightforward. So we will be asking you to calculate using a formula, and then using that number that you calculate, we get you to interpret and we get you to compare. Okay, so the straightforward part is the calculation. Then you need to actually be able to think, to interpret, and then to compare and make some sensible kind of comment in relation to the problem that you're solving. So it's not just a straight, what's the formula, what's the answer? It's what's the answer and then explain your answer. Okay, so you might do some calculations and say, calculate a Z-score of 1.2. Or you might do a calculation and calculate a Z-score of negative 2.7. Or you might calculate a Z-score of 0.4. Okay, it doesn't really matter what the numbers are at this point. The first part of being able to interpret is to be able to identify where on the graph these values would fall. So a Z-score of 1.2 is greater than 1 and less than 2. So on your graph, it would fall somewhere, this 1.2 would fall somewhere here. Greater than 1, less than 2. Less than halfway between both. If you're doing negative 2.7 Z-score, obviously it's smaller than negative 2, but it's bigger than negative 3. So it's in there somewhere. Negative 2.7 is that one. And a Z-score of 0.4, I'll put that in there in a different colour. 0.4, obviously greater than 0, less than 1, so it'd be somewhere here in that section of the graph. So we don't have to be super accurate with this positioning of the Z-score on our graph. The thing we need to be able to be very confident of is which section does it fall in. Okay, so the section it falls in is the bit that I'm interested in, not exactly where on the graph it is. So as long as I know that 1.2 is bigger than 1 and it's less than 2, I know what section it falls in. I'm happy. I can like interpret it from there. All right, so let's have a look at one. So on your booklet, page 28 has this page in it, and it's asking you to use that information that we've been looking at previously to be able to interpret. So again, remember that we call the right-hand side of the graph the top part of the data and left-hand side the bottom part of the population. So having a look at if a Z-score or a value, a Z-score falls in section A. So section A is here and basically means the Z-score would be bigger than 0 and smaller than 1 to fall in that section. So it could be a Z-score of 0.6, or it could be a Z-score of 0.25, or it could be a Z-score of 0.9. All of those Z-scores there would fall in that section A. So as long as you know where it is, you can go, okay, it's in section A, it's in that part of the graph. It basically means it's in that section. So we would say something falling in section A, we shade in section A and then everything else to the right of it. So we're looking there and saying, okay, if a value falls in that section, section A, we would interpret that as being in the top 50% of the population. If our value fell in section B, which is on the left-hand side of the graph, in here, we're going to say, let's shade in section B and everything to the left of it, And we know from our previous examples that anything less than -1 standard deviations there, that would be represented by 16% of our population. And we know that's the bottom section of the graph. So we would say if a value fell in section B, we can interpret that that person falls in the bottom 16% of the population. Using symmetry, section C, so say a z-score of 1.6, or a z-score of 1.8, or a z-score of 1.1, somewhere in here. This section here, coloured in, would represent a person, or the score for that person, falling into the top 16% of the population. If I was looking at section D, so I might say I've got a real smart cookie in my class and they have scored a z-score of 2.6, that would put them in this section of the graph, and I would interpret that as meaning that they would fall in the top 2.5% of my population. So really high scoring on their SAC. So I think that probably gives you enough information to be able to answer that section and have a bit of a play with interpreting the scores. Now on a SAC, a further maths SAC is quite open-ended, and we might give you a question that would give you some information about Jane and her further maths and her psychology scores or whatever. And it might ask you to calculate a Z-score, interpret, and compare which subject did she do better in. Okay, so you've calculated 2 Z-scores, let's say, and you figured out that in further maths her Z-score or her standardised score was 1.2, and in psychology her standardised score or her Z-score was negative 0.85. And I might ask you to interpret and compare. So basically what you need to be able to do is to be able to first of all identify where on the graph do these two scores fall. So if I put her further maths score there in pink, if that is the mean there, or 0 standard deviations there, this is 1 and this is 2, 1.2 falls in there. So her further maths score fits there. And her psychology score, I'm going to put in a different colour, negative 0.85, so in here somewhere. So interpreting would require me to tell the reader what percentage of the population does she sort of fall in. So for further maths, her SAC score would fall in the top 16% of the population. And for psychology, her score would fall in the bottom 50% of the population. So if you're able to identify where they fall on the graph, and then you can put a percentage to them, top 16% for further maths, bottom 50% for psychology, that's the interpreting part. And then I might ask you to compare them. And I would say, obviously, she's done better in further maths than she has in psychology, full stop. So just a little bit of a, maybe you might want to make some notes or something about this. When you're interpreting a score, you need to identify where the score falls on the graph and what percentage of the population is she in. And then when you compare, you basically need to say which one's better and why. So just keep in mind, because we do make it a little bit tricky sometimes. Sometimes it's better to get a high score, and sometimes it's better to get a low score. So when you're saying top 50, low, bottom 50 or whatever, that's okay. But then when you're comparing, sometimes it's better to be in the bottom part of the graph than it is to be in the top. So if you think about things like test scores, IQ tests, things like that, it's better to be high. You want a high test score, you want a high IQ test score, those sorts of things. So it's better to be on the right-hand side of the graph for those types of things. But something like running, so if you were doing a running race, the winner gets the smallest time. Okay, so sometimes it's not good to get a high score. So you do need to keep that in mind when you're interpreting and comparing. Okay, so hopefully that gives you enough information to be able to complete the section in the textbook and complete the section in your booklet on Z scores and interpreting and comparing them.